Welcome to episode 12. In the previous video we looked at switches and things and we saw a conditional switch. Today we're going to look at what is a thing, and the thing today is a UK traffic light simulator using 3 LEDs. So things and switches, here we go. But first, please subscribe to the channel, click on the like button, click the bell icon to get notified, and support me on Patreon if you can. There's a link in the description below. Now, I'd like to say that working out the phasing and the timing on my little set of traffic lights was easy, but it wasn't. UK traffic lights go from red to red and amber for a little while, then they go green, and then just before they go red again they go amber on their own and then go solid red. So rinse and repeat. Now the proportion of each cycle which each colour uses is kind of up for grabs. I've made up my own to make it easy to have integer multiples of duty cycle percentage. So if you look at each of the bars across the top representing the period for which the light is on, it's just like a blinky, but it's got a very, very long, what they call, period and a slightly different duty cycle each time. So I'm using the features of H4 plugins that do that kind of thing, but to save time, space, programming and loads of other stuff, we only ever use integer arithmetic. So I have to do a little bit of juggling, or a lot of juggling as you can see from this spreadsheet, to make sure that my duty cycles A represented roughly what the traffic light pattern is, but B could be used in with integer duty cycles. Anyway, moving on. There's our little traffic lights on the right, and you can see them going through the sequence. So there's your solid red, there's your red and amber, there's your green. Wait a little while, there's your amber. So you can see the timing isn't uniform between them all. It's, the amber's only on for a short while on the way back up, etc., etc. And what I'm going to do, just for the moment, is stop that. Okay, with a simple press of a button, and then we're going to look at the code of a thing. Now what I've done is I've folded up the traffic lights code. Well, we will look at it, but that's a sub function it uses. But the reason I folded it up is specifically to show you that the thingness of your code is irrelevant. It doesn't matter what it is that the thing is. In my case, it's that function called traffic lights, and what that does is run a very complex sequence of timing on 3 separate LEDs. Now, when I put the thing on, that's what it does. When I put it off, that's what it doesn't. And the point of the thing is it can do anything, but it will still respond to all those other functions and features. So I can turn that on by telling my Alexa voice control to turn it on. I can turn it on with MQTT. I can control it from another H4 by sending it a REST command, all that stuff. Or I can press the button. Fully debounced, of course. So let's briefly look at the kind of code you're used to seeing already. Just a few definitions for the LEDs there, look. Then we have the pin machine, which manages all inputs and outputs. And the outputs are a red lamp, an amber lamp, and a green lamp. And the rest of the code is everything that you've seen before. We've got a Wi-Fi connection, so in a moment I will fire up the web browser and we can have a look at that, watch it working. We're connected to MQTT. We don't have to be, it's just handy that we are. We can control it with MQTT, and I might well do that later as well. We've got a binary thing. Here it is, the thing that can only get better. And the code amounts to saying, let's have a binary thing controlled by this function called traffic lights. It's a UPnP thing as well, so if I wanted to say, I could say, Alexa, switch on traffic light sequencer. But it's a bit of a mouthful. I'm sure she hasn't discovered it yet. I'm not even going to try that. And then we've got the multifunction button, which allows us to just stab it on and off, or indeed reboot it or factory reset it like anything else. So hundreds of tons of functionality. While we're talking, and because it might not be simple to do, I'll just get the web server up, so just bear with me a second. Okay, I'm back. I just set up the screen there so that we can look at the remote controlness of the thing. So first of all, on the left, have a look at the web interface running on the device. As you can see, it's you can't because I haven't got the other jobby up, but you can imagine these are the D6, 7 and 8, they're the LEDs, that's the sequence operating. The fact that it's on means that we can switch it on and off. Turns it off. Okay, back on. We can also use MQTT because, as we can see from the web UI, we're happily connected to a MQTT server. So I'm just going to go and send that a toggle command, which will flip it the other way. So it's on, that will turn it off. Toggle, it's off, that turns it on, etc., etc. Now I'm just going to see if I can do something. No, I'm not. I'll pause it, otherwise I'll screw it up. Yeah, not as tricky as I thought. Let's try that again. So there we go. Look, you can see that the lights follow the actual beast. Yeah, so we can turn it off. We can then use the button to turn it back on. We can, if we want to use MQTT, I won't do that again because I have to keep swapping the screens. I just want to show you that the two, we can use the little built-in console here. We can say H4 toggle. There we go. So we've got a variety of ways of controlling the thing. And the thing is, run that sequence. That sequence. Okay, you happy with that? We'll go back to the code. So you've seen how all of that works with the remote control and everything. Let's just very briefly, because it's not the point of this, we will look at the code that actually makes the traffic light sequence, because it's interesting to see how H4 functions are used in Anger. So let's then look at this function here. It's a sub function called by the main traffic light function. Basically it switches an LED on, and then after a certain period of time it runs a function to switch it off, and then once that off function has occurred it then runs something else. So it chains in another function, and that's the kind of fundamental thing. So basically what the main sequencing thing says is turn the red light on for a certain amount of time, and then when it goes off, turn the amber light on for a certain amount of time, and when it goes off, turn the green light on for a certain amount of time, and when it goes off, go back to the red. So that there, the switch on, is the kind of core of the actual switching on and off of the lights, and the traffic lights function actually does the sequencing. So let's see here how it does that. I'm just going to make this a tad wider so that we can, no I'm not, just bear with me a second. Oh no, still I can't tell the difference between a control and an alt. Hold on. No, this is just really not helping, is it? I'm really sorry about this. Bear with me. Right, okay. Many apologies there. I'm still getting used to this fancy presentation work. Anyway, look, there we go. So what happens here is we have a timer, an H4 timer called running. Now that basically is our kind of internal state variable. If running has got a value in it, then we're running the sequence. So if somebody has said thing on, then running will have the value of that timer in it. If somebody has said thing off, it will be null. So we come in here and we say if we're being told to turn on or turn off, one of two things. So let's look at what happens when we turn on. So when we turn on, we switch on call that switch on function for red light of a time t1 plus t2. Now these t1 and t2 are those times taken from that spreadsheet, the phasing spreadsheet, to ensure that we get integer numbers in a reasonable sequence. So basically, turn the red light on for the sum of those two, and then run a function which says once after t1, switch on the amber light, which will stay on for t2. When it goes off, switch on the green light for the amount of t1. When that goes off, switch on the amber light for t2. That's it going amber on the way back up. And then if we're running, this is a bit tricky, it's a bit of recursion. If we're running, then reschedule yourself. Basically, it calls itself to just repeat. And it repeats for a period of 2 times t1 plus t2. And that's why we've got to get those phasing values as integers, because otherwise there'd be a gap in the sequence that wouldn't exactly overlap. So all of the separate subtimes have to add up to exactly the amount of time that we can easily determine to repeat the sequence, if that makes sense. If it doesn't, I'm sorry, but there you go. That's how it works. Otherwise, if we're being told to go off, we use the H4 timer function to cancel all. That basically stops all timers. And the reason we do a cancel all is because we've got the running timer, we've got that once timer, we've got this every time. We've got 3 separate functions going on there, and we don't know at what stage each one is in. It would be a nightmare of maths to work out the exact time of what each stage was. Nonsense. Just cancel everything. Say we're not running, and then turn all the lights off. So that's that's the thing. That's what the thing does. All of that complex sequencing there. But none of the things that control it and turn it on and off need to have any clue about that. You just wrap that all up into a function, stick it into your binary thing, and as Forrest Gump says, that's all I got to say about that.